Okay friends, in this section we are going to discuss the fault locations and the parameters required for the fault of our system. Suppose we want to know the fault current when fault occurs near to the bus number 1, or the fault current when the fault occurs at 50% of the transmission line, or at the end of the transmission line, or maybe on the buses of our system. How to define the fault resistance and impedance? Let's start. First click on what apparatus the fault is going to occur. Here we consider the transmission line. Suppose at first we want to know if the fault occurs near to the bus number 1, what will be the fault current? Click on the transmission line, right click, then calculate. From calculate, short circuit. Click on short circuit. Go here. In short circuit, the basic options go the method of calculation of the short circuit current, that is the fault current. Here we select IEC 60909. Another method is also there. You can go to the index and you can find the methods, and maybe others are not so much approximate. We are considering IC. Then the fault type, this is 3-phase. We can select single phase to the ground, we can select 3-phase to the ground, or triple line. We can which type of the fault do we want to know? So phase to neutral, here we select one single line to the neutral. Then the maximum short circuit current. If you remember, from the protection system point of view, when the fault occurs, for the relay settings of the plug setting and time settings of the relay that we connect to our system, we just do the system, we require to know the maximum fault and the minimum fault occurrence. So here also, according to your desire, you select which type of the fault current do you want to calculate, maximum short circuit current or minimum short circuit current, whatever, go to your desire. Then short circuit duration, you want to know that, for example, if this short circuit is occurring for after break time of 0.1 second, or the fault clearance time. These are the parameters that you need to specify. Use break time. The fault impedance, you can give the resistance and the reactance. Then suppose, for example, I want to consider now my fault is occurring through 0 impedance and 0 resistance. Then we keep it as 0, otherwise I can give any value that my requirement is. The fault location, you can select the bus bars, junction nodes, all the bus bars, or user selection, that where it should be selected. Okay, go and you can select here where the fault should occur, and you want to consider the fault current in which location, on which parameters. We don't go through this portion because we want to know on the transmission line, but on which location of transmission line. Let's consider here the short circuit at the branch or in a line, the fault distance from the terminal of 1, from terminal I is given here, in which the relative we can give in percentage here, that for example I want to know at 1 kilometer away from bus number 1, I want to know the fault current when the fault occurs 1 kilometer away from the bus number 1 here, for example. Then I should give, according to the percentage, what is the total length of the transmission line that I considered at initial time. Then for example here at 1 kilometer, if the total length that we have already given, this is 100 kilometer. For 1 kilometer it becomes 1%. Now we consider only 1. Then click execute. Okay, here was one problem, that initially we have considered our single line diagram. It means from of three lines I have considered only single line diagram. So here I go through the calculate, then from short circuit the fault type is, I select here 3-phase short circuit. Then all the parameters as we have already explained before, then execute. Now if you consider the fault is at 1% away from the system, this is the amount of short circuit. Whatever the MV is given, another the KA, the short circuit amount of short circuit has been given, and the peak value of the short circuit, which is given IP 43 point something kiloampere. Now for example I want to know at another location this fault current. For example I want to know at 50% of my system. Then go execute it. Then at 50%, what will be the fault current? Here it is. At 50% of the transmission line, this is the fault current, MVA fault current and peak value of the fault current. Before it was 43 the peak value, and now it becomes 1.2062 kiloampere. You can consider that whenever we go away from our feeder or our source, when we go away from the source, when the fault occurs furthermore away from the source, the fault current reduces. This is whatever we wanted to understand and recognize, we visualize in the by Dixile.